welcome to Hydro.
Thank you. Thanks for setting up the tour.
Yeah.
I'm excited to be here, and I'm really thankful, to the whole marketing team. So thanks for
check out the shop.
All right, let's do it.
Nice to meet you, Chris
Nice
Miller,
to meet you.
Operations.
So tell me, you said Chris Miller, Operations, so you cover all of this, right? And how do you, I guess, stay motivated to be here and take care of everybody?
The people are great. We have a great team. We work together. We stay motivated because we're growing. Learning from the older generation and then bringing in new people has been a big motivator for us. Luckily, I've been here for 11 years, so I was fortunate to come when I did. But now we have people who are coming here now, and I'm teaching them stuff, So, I'm still learning from the older generation. I'm teaching the younger generation. So,
what is your favorite thing in the shop?
My favorite thing in the shop is probably when the pump shifts.
I was gonna say. I thought you were gonna say that.
We're very on to the next one.
Yeah.
We really, it leaves, and you hear good news from the customer. The customer is appreciative, but we're on to the next one.
Yeah.
We really move on pretty quickly to the next one, and as long as the quality's there.
Yeah, check. I love it.
So here's our machine shop side. We did just develop a supplemental weld shop right over here because our business has grown into a lot of fabrication. So we have another 2 sets of welders over here, and then another weld shop over there. And then over here we have our machine shop. We have a VTL, horizontal boring mill. We have a surface grinder, ID grinder, some mills. And then over here we have some CNC machines and some lathes. So we're able to machine everything. We do have a very strong outside machining team who follows our QA program, and they're all local vendors, so our QC can go in, they can inspect the parts, they can do everything, dimensional, visuals, everything at the other vendors, even PT. So it's very important to have a good team.
What is this here that's being welded?
We have a discharge head, a new fabrication that we're welding, a series of 8 pumps.
Okay. So I'm fascinated with some of how the machines, they're so old and they're still up and running, but then we kind of get new machines as we go, but they're still working, they still do the job.
You don't get rid of a machine that's busy, and you don't get rid of a machine that works.
Right.
So we have discarded machines that either didn't work or we weren't utilizing very much. That's how we built the weld shop. But otherwise, we use the mills. We have 2 shifts. We're very excited to be busy and growing, so we keep the machines. We'll be expanding.
It'll keep expanding.
We keep the machines.
Yeah.
Yep. Over here we have the CNCs. We do a lot of impeller trimming, wear rings, and other critical dimensions here, and then we fit them in with nitrogen or heat, and then they just transfer it over to the mechanic side.
Now these parts come in, are they machined here? So like this here, is that brought in, or is that done completely?
This is brought in from one of our outside vendors. So we bought it as raw material. It goes through our QA process, our QC, UT, and then we send it out for machining, or it stays here, either or. But then we'll send it out for grinding, and then threading will happen here, and then we'll use our certified gauges to check it. Our QC does a full dimensional, PT, visual, everything that's required by the job, and then it's ready for assembly.
All right. How many people do you?
We have about 30 shop employees, and then another 50, 60 in the office.
Okay.
We have a very large engineering team, QC, quality as well, and then we have a very extensive contracts and other staff.
I love this machine too. Like I said, it's one of these old ones that I know I can just see the worker, right? And it's still in play, it's still needed, and you're training people too. I know is a big part of Hydro.
It's important to bring in some of the younger people, and like I said, the machine, if it doesn't break, if it's not broke, don't fix it. We do a lot of stuff. We can machine shafts in-house. We can do threading, everything. So we keep busy.
Awesome. I love this teamwork behind the scenes too. I can see it happening. So good.
This is our quality department. We have we can do everything: VT, PT, UT, and MAG, MT. Everything comes here for inspection, and they'll hand this stuff over to the mechanics for assembly. Right here we have some finished shafts that are going to be here for inspection, some column pipes, our customer supplied column pipes, and then we have our reverse engineering group. So when a pump is for repair, it comes for inspection, and then it'll go for reverse engineering, so we can, you know, remanufacture this in the future. This is an impeller for repair.
Yeah.
We'll get this in, we'll do an inspection on this. If it can be repaired, we will repair it. Okay. It'll go through contracts and then engineering, and then it'll go through quality. Everyone approves, and then we'll go through, you know, welding, grinding, whatever we need to do. If the shaft needs replacement, we'll do. And then any other rotational parts. Here we have a small part for PT, so dye penetrant. We'll see, and if it passes, it'll move on probably to hydrostatic testing. We have a shipping receiving area where they'll package everything that's necessary. And then here we have some more parts, either raw material or more parts that are finished machine for inspection. And then this is a very large pump, and we will 80,000 pound pump, and we'll build this.
Wow, wait, did you say, tell me again.
80,000 pound
80,000 pound pump.
Yes.
Okay,
and we'll build it at a vendor of ours, local. Our mechanics will go there, work with their people, and build the pump.
Wow.
So it's important to have all these local vendors working with us under our QA program. That way we can, you know, keep the quality level and have the support we need.
Yeah, the end user is going to appreciate that very much. Yep.
Here we have some open face impellers waiting for inspection.
I don't think I've seen that one that big before. I know I have on trade show floors and stuff, but.
So these will be balanced, and then when they are assembled into the pump, and we'll test it at our testing facility. And if the performance is, you know, we're trying to get the performance in a certain range, they'll come back to us and we'll put them on the CNC, and we'll trim the impeller, rebalance, reassemble, and test it again to get right to the right spot for performance testing.
Where, as far as this goes, is there something that it connects to, like in here?
Yeah, there's a shaft somewhere. We don't have it right next to it, but
no. And then this back here, what is?
This is a wet end. This was tested recently at our testing facility.
Okay. I've never seen it out in the field, so you know, it's like, to me, it's like, what? I'm just trying. So
these are
other side, it flows through there that way.
Yeah, no, the impeller is right here. The bowl, the impeller is in there, and then that's the suction bell.
Okay. Okay, so it comes in.
And this is a one-stage pump.
Okay, got it. Sorry, I'm learning.
The water would come through here.
Yes.
Flow through here into one of these column pipes, and then out a discharge head.
Okay, wonderful. Now I understand.
We'll just rotate. It's a little bit easier.
We go out into the field and see this, but you don't see the pump because it's hidden.
No, you almost never see it. So you'll likely just see like a discharge head right here. Here you go. Hi. This is Bill's song.
Over here, got the impeller up there on here.
So he's drilling into the wear ring.
Yeah.
He's attaching the wear ring onto the impeller. See those bolts?
Yeah.
So those are inserted into the wear ring is threaded, and they're inserting into against the hub of the impeller, and then they're going to machine off the head. It's another method of almost similar to set screwing the wear ring onto the impeller.
Well, you're running a great facility here. It sounds like, you know, #1 priority, quality, getting it out to the customer as fast as you can, and checking that box is kind of one of your favorite things, right? Like most operations.
Yeah, we do what we can. We're busy, we have a great team, and that's what we're excited about.
I have to say that everybody that I've actually met at Hydro and worked with has been remarkable. So I love being here. I've been to several facilities now. Just being able to see the difference in industry and how y'all support each. You know, this is where you support the nuclear industry. Yep. And so, yeah, it's just a vast of ways of doing that. Everyone's a little bit different, unique for that industry. I mean, I'm seeing the activity. But are you really seeing an uptick in like the nuclear space?
Yeah, we're nuclear is growing and we're growing with it.
Okay,
That's
wonderful.
the most important.
All right, I'll let you get back to work.
Right, thank you. Nice meeting you.
Yeah, nice to meet you too. Can I do that? I want to try. All right, tell me what to do.
Okay, so you press the button to start,
All right.
and then you want to start in an area with dot.
Okay, so like around.
Yeah, so you just press it.
Press it harder.
Yeah, I guess so.
Okay. Well, what if you don't go fast enough? Does that matter?
If you don't go fast enough, that's fine. If you go too fast, you can miss
It'll let
something,
me
right?
know. So I gotta get all these ones. So I want to make sure I get all those dots. But then, do you go back this way? Does it matter?
No, you're still picking up data, or even if
So
you
I can just-
overlap, that's fine too.
Okay.
You want a job?
Yeah, I'm doing great. Thank you. I can connect the dots. Oh, great. You know, color by number. I
So
like
right
that.
now, if you look closely, you can see it's like 28 lines overlapping.
Yeah.
And if you want to go deeper into like a hole or pocket,
Okay.
whatever, you double click this, and now it's just one line.
What'd you double click?
The middle.
Middle? Okay. So now I'm going
so now
in.
You go deeper
So you see the one green line now? So now
So that's what I'm
you can
doing.
focus on a small area.
Yeah. So if you miss a small area and you want to get that area, you
All right. So I want to like go over here because there's some damage. So what
Yeah.
happens when you see the damage?
it still picks up all the damage.
Okay.
Yeah.
All right. Do you want to finish out? Because we need you on this, not me. But I was having fun.
It is fun. I mean, this is actually part of the fun part. Is
Yeah.
You get to have all this technology and play around. And we have
yeah.
multiple different scanners.
He's
That's
a lot
handout.
faster than I am. I was going like very methodical.
With training, we'll be able to work with you.
I will point to the success, right, of the expert.
We actually invested in multiple systems because of being able to be flexible. So if we have to travel on a short notice, we have a system here that's it's an ARM-based system where basically you have the same scanner deal. You have a probe also, that doesn't have. So the probe is 1,000 accurate. The scanner is maybe 2,000 to 3,000.
Okay.
But it's fixed to the arm, so that's how it knows where it is when you scan. So you see the markers. So those reflective
Yes.
dots are actually the alignment process for that handheld. But to ship this in the box, you need a tripod. You need like a week advance notice.
Okay.
With that handheld, you just throw it in a carry case, get on the plane, and you go. You know.
Okay.
So, but you have to adjust the strategy for the number of parts, how big it is. So we have another type of scanner which is offsite now for the larger volume stuff. So we combine everything and try to make the best of it.
So the dots, you put those on there. This is standard
Yeah, so
based
these,
on the side.
So these are actually our dots. That's a magnetic one.
Okay,
so
don't
buy
scare
them.
me.
Yeah,
We can if you want.
Yeah, that's cool.
so these are magnetic, and then you have stick-on ones. No, these are consumables.
Okay.
So we have to buy new ones every now and again. You might
right.
see there's some dots lying on the floor, so you
Yeah.
scrape them off. But so it takes a little bit of time to set them up. Whereas with this, you just plug it in and start.
Yeah. Okay.
So there's pros and cons. Yeah. So this is
Thank
starting
you.
up. So this is actually quite a nice system, and this is our mainstay.
Oh.
So you still have.
Still got a gun.
You still have.
All right.
You still have a laser line. So the line is actually a blue laser.
Okay.
And it's actually points. It's 500,000 points.
Okay.
And then there's a camera. So the camera is actually triangulating the position and gives you the coordinates. So what you're doing is you're collecting millions of X, Y's, and Z coordinates. And then you can switch to a probe. So if you wanted to just do a circle more accurately, because we have to measure the fits as well, then you can switch to the probe. So it's a 2-in-1. And they're pretty flexible, and we've been using these. So these are metrology grade type of instruments. You get a lot of different type of capture systems, but some of them are just good enough for like a statue or artwork. So these are like 1,000ths of an inch accurate, so very nice system. So, but you see that's one line, and it's only this wide.
Right.
Where there you had 20 lines, so you get much more coverage, I guess, much faster. So for us, it's about being efficient. This is one of the first stages, just capture the data.
Yes.
We still have hours and weeks of work trying to create the models and come up with engineering and do all that stuff.
So once it gets on the screen, like we saw earlier, what happens then? I know
So
it goes
that's so on the screen you just see it's basically the measurement.
Okay.
So it's a dimensional measurement.
Okay.
We have other instruments can take materials and all the rest. So once we have that, we save that, and then what we do is we create sketches on that data. So we extract basically 2D sketches and 3D sketches, and then we switch from this software to another software, SolidWorks, and
It's all digital.
And there we
now.
do all our digital modeling. So we create 3D models. So nowadays, people used to have 2D, but we sort of go 3D then 2D. It's interesting.
Okay.
So if you have the 3D, you can make 2D drawings. You can send the 3D to a machining center to machine it. You can send the 3D file to a pattern maker to make a pattern. You can use it for an assembly and explain, communicate how things are moving. You can send it to an engineer so you can run computational fluid dynamics on it.
Yeah.
You can actually simulate the flow in the pump and all that. So everything comes from the 3D. But because we don't have a design, this is the fastest way to digitize
Yeah.
to get to the 3D.
Yeah.
It still takes a lot of hours and work. So he spends an hour, 2 hours getting the data, and then how long to go and make a model.
What's the red?
The red is what it's capturing at the moment.
Ah.
And if I press again, then it processes the red into the blue. So that's how you know.
Got it.
And then yeah, you don't need markers or anything for this. So if I scan over here, it'll pick up.
You can put your hand down there too, you can scan it.
Yeah.
Yeah,
I
put your-
can't.
Might be a little weird if you move it all, but
Oh, now I'm
Put it
ready.
on the table so it's stable.
So it's like we're together. Oh, okay.
There you go. Don't get it fried because
Now you've got my fingerprint.
you see it, it's actually pretty detailed.
Look at those nails. I love it. I love it.
So, you know, it's a nice tool.
Yeah, well, keep doing good work. It's nice to meet you.
It's a nice visual way to show people what we do, but it's only the beginning, you know.
Yeah.
So if you talk to other people in Dabu and engineers, so a lot of
Yeah.
the pump work and the design work happens on the computer.
Okay,
in the
well,
back-
we
in the
told them to
background.
get ready. We're coming to see some
Good,
of
so
that.
then they can show you. So all the work you see, you know, the Hydro University, all the models and stuff they explain, some of the Centaur, the monitoring where they show the pumps, it all sort of started by collecting data and then 3D modeling and creating.
I know, I've seen the Centaur. I've been like in front of it.
I
you
know,
the
it looks
screen.
nice, right?
Yeah.
So that's
All
it.
right, well, thank you so much.
You're welcome.
I'm
Hello.
Charlie.
Tuan, nice to meet you.
Nice to meet you too. What do you do here?
I'm a senior engineer. I've been with Hydro for more than 13 years. And here you can see I'm working on computational fluid dynamics for pump design.
So, what is the difference between like the red and the blue?
This shows the pressure distribution in a pump, like how the pressure is developed when the pump is operated.
Okay, wonderful. Thank you. Can I meet some more of your team?
Yeah, of course. Here is Ravi Somapelli.
Hi.
He's our
Nice to meet you.
senior engineer.
Come on here, I'll show. Today I'm working on reviewing one of the performance test data. So what we tested and what the OEM curve was, I'm showing the difference here today.
Where's the efficiency point?
This is the efficiency point here. This one is the efficiency point.
I just want y'all to know that I'm cool. That's why I said that.
This
All
is
right.
Victor Sanchez.
Hi.
He's another engineer in our team. And he's new. He's been with us for more than a year. Victor, tell us what you are doing.
Well, first, Victor Sanchez. I came from Zolzer, another pumping company. And I've been here working for Hydro for a little bit more than a year and 4 months. And right now I'm working on this pump, like the vertical pump. And I'm doing the design report, which contains all the calculations to ensure that the integrity of and the function of the pump.
So you really like pumps too?
Yeah.
Yeah. From
Yeah,
you,
I'm
once
trying
you're
to-
in the industry, you just kind of stay.
I'm trying to keep learning too. Yeah.
Awesome. Well, nice to meet you.
Nice to meet you.
Thank you.
Alright. So next is Omar Alonso. Omar is our CAD operator. He's been with Hydro for
Hi.
about 13 years.
Nice to meet you. I like all your drawings in your
Yeah.
office.
So Omar is in charge of all of our modeling, drawings. Omar, can you show us something?
Sure. I was working on a pump test stand.
Like for this facility or a different facility?
It's for a customer.
Oh, okay. For there.
For pump storage.
So you still like design after all this time?
Yes.
All right. And you got a lot more, I guess, cool tools to use, right?
Yes.
Over the
I
years.
enjoy using SolidWorks. I've been using it for probably about 20 years.
Well, it's nice to meet you.
nice to meet
Thanks for your time.
Another team member is Emmanuel Huerta. Emmanuel is our CAD operator.
Hi.
How's it going?
Good. Nice to meet you. What you working on?
I'm trying to update the bolts on this assembly because since we already updated also the bolt hole and everything else, and supposedly I updated it, but SolidWorks didn't, so I have to check each one right now. So that's a whole pump
Well,
assembly.
you don't realize how important the bolts are, actually. It's a huge deal in the alignment, right?
And earlier I was working on a coding sketch pump assembly.
Beautiful. Well, we won't take all your time because we know it's important work, but it's nice to meet you.
Nice meeting you. Take
Thanks.
Okay, so we can continue with the other side.
All right. Lots of engineering.
Yes, so engineer. Okay, meet Vu Nguyen. He's another senior engineer.
Hi.
He's
Nice to
specialized in Goon's pump product.
Yeah, I think I'm a senior design engineer here. I've been with the company for like almost 13 years. So we did specialize on a little small pump and goose brand.
I was gonna say, this is your favorite pump?
Yeah, but it includes a range of pumps with different application and everything. So we usually get the request from the customer. We figure out which pump and design that we can meet the requirement, then we start from there. So right now I'm working on a project that will supply several pumps for a U.S. nuclear power plant. So we complete the design, we already manufacture the pump. We're working on the FEA analysis to prove that the design meeting the seismic and stress requirement from the plant.
How many of those pumps normally go into a nuclear plant?
So right now we are supplying 3 pumps in a series. So, but in potential they're gonna buy like different more sets of that. So 3 at a time.
Okay, awesome. Well, it's very nice to meet
nice
you.
to see
Thank you, Vu.
Keep doing the good work.
Meet our friend
Yes.
Javier Contreras.
Nice to meet you.
He's a senior project planner. How long have you been with us?
I've been here for 32 years. We used to be like 4 of us in the old days. I used to do the reverse engineering, make drawings, planning, travelers. Now I'm just doing project planning for
When you were
non-safety pumps.
When you started, how did you do the reverse engineering? Was it paper? Was it computer? What did it look like?
Yeah, everything's done in paper. Actually, I have an example. Would you like to see?
Yes, I would. Oh,
Here's
wow.
some of the old drawings made by hand. They look like a computer drawing.
Yeah.
This is a shaft.
Look at that. See, I feel like this is just art.
In
know?
many ways it is.
Yeah.
I was trained as a professional drafter.
So this is one pump?
Yes, it's 107 7/16 of an inch, and it's 5 inches, and you can tell they have different kinds of serrations.
Well, I don't know that I can
measurements.
tell, but y'all can tell, right?
Right. So this is just an example of some of the drawings that I created
Oh, wow.
back in the old days. Now we still do this
I
stuff.
know this is a bolt.
Yeah, it's a bolt, right? This is tiny little details that go into the parts. And I kept this because sometimes I travel and help Warner and his department to reverse engineer stuff. So I'm quite an expert.
Yeah, you are. And 32 is a lucky number in our family. So
It
you're
is?
going to have a great year. So
Oh,
it's so great
thank you
to
so
to
much.
meet
I
you.
appreciate that.
Yeah. Wonderful. Thank you.
Thank you.
Thank you for your time.
Yeah.
Amazing
Oh, yeah.
team.